So welcome to our today's lesson. We are going to do the first part of radioactivity. And below are the objectives of the lesson. So just to begin, isotopes can be stable or unstable. The unstable isotopes do emit radiations to become stable through a process that is called radioactivity. And this radioactivity is what is forming the basis of our today's lesson. So mentioned earlier back in Form 2, some elements have nuclides having a neutron-proton ratio of 1:1. So we have neutron proton ratio of 1:1. This means that for every one neutron, there is one proton. But then sometimes, as the size of the nuclide increases from the first element and the mass number keeps on increasing, a point is reached when the neutron-proton ratio is more than 1:1, and in this case sometimes it is 1:5, so 1.5 to 1. This means that the number of neutrons is more than the number of the protons. When this ratio is reached above 1.1, above 1.5:1, the stability of the nucleus becomes unstable. That is to mean, when the ratio now goes to 1.6 to 1, such that the number of neutrons is above the number of protons by this ratio, we say that the nuclide is no longer stable. So always for 1:1, this is a stable nuclide. Below this ratio, we say that it is also stable. But then a nuclide having 1.6 to 1 ratio, that is the neutron-proton ratio, these nuclides are unstable, and they are the ones that gives or yields what we call unstable nuclides. These unstable nuclides undergo what we call radioactivity to attain stability. This is usually accompanied by emission of radiation in form of particles and energy, like we are going to see in our lesson today. So, radioactivity generally can be defined as the process where an unstable heavy nuclide breaks up to yield another nuclide of different composition with release of charged particles and energy. So, we see we can have a nuclide that is unstable. When it undergoes what we call radioactivity, it yields nuclides, and then there is also release of particles that we will be seeing later, and also energy can be released as well. The substances that undergo radioactivity are referred to as radioactive substances, while the radioactive isotopes are known as radioisotopes. The spontaneous random emission of particles and energy from radioactive nuclide to give out particles, these particles, to give out smaller nuclide and particles, these particles, with the release of energy is what is referred to as radioactive decay. Back in Form 2, we mentioned or didn't study what are chemical reactions. And now, what we are introducing is radioactive reactions. We have a number of differences between the nuclear reactions and chemical reactions. So comparing the nuclear reactions and chemical reactions, the nuclear reactions take place inside the nucleus. That means that if we are going to have a nuclide or an atom with energy levels like this, nuclear reactions take place inside the nucleus of the atom. When we get to chemical reactions, on the other end, they take place outside the nucleus and involve electrons. Our nuclear reactions, of course, involve protons and neutrons. So for this case, if this is our atom with the nucleus, the reactions that are chemical will take place in this region called the energy level, where the region is filled by electrons or occupied by the electrons. Number 2, during nuclear reactions, the nuclei of the atom changes completely and new elements are formed. But then in chemical reactions, elements retain their identity and the nuclei remains completely unchanged. Again, the nuclear reactions cannot be influenced. We are saying, number 3, that the nuclear reactions cannot be influenced by environmental factors such as temperature, pressure, etc., but then the chemical reactions are affected by environmental factors such as temperature and pressure. This means that you cannot be able to vary the rate at which the nuclear reactions are happening by altering the temperature or pressure. But then, like it was seen in the rates of reaction, chemical reactions can be altered, or can be the rate at which the chemical reactions take place can be altered by either increasing or decreasing of the temperature, or increasing or decreasing of pressure. Difference number 4, nuclear reactions are accompanied by release of a lot of energy in form of heat. But for chemical reactions, they are accompanied by release of little amount of energy that can be in form of heat. Number 5, in nuclear reactions, there are no bonds that are broken to form new bonds. However, in chemical reactions, old bonds are usually broken to form new bonds. An example, for chlorine, which is a diatomic molecule, to react with sodium, it is a solid, the covalent bond in chlorine atoms or molecule must be broken to give us separate atoms, and these separate atoms are the ones that now react with the sodium to form the chloride, the sodium chloride. In that case, old bonds have been broken to form new bonds. The difference number 6 is that nuclear reactions are irreversible. But then, for chemical reactions, they can either be reversible or irreversible. And those are the main differences between nuclear reactions and chemical reactions. Remember that radioactivity can either be natural or artificial. Natural radioactivity is the process of radioactivity that takes place naturally, whereas artificial radioactivity is the process of radioactivity that is induced by man-made methods. We have types of radiations that are mainly three. So types of radiations. We have the alpha as the first one. That is stabilized by the alpha. Then number two is a Greek letter alpha that symbolizes alpha radiation. And number two, we have beta radiation that is symbolized by the Greek letter beta. And then number three, we have gamma radiation that is symbolized by the Greek letter gamma. The alpha radiations are basically, these are the characteristics, they are basically the helium ion that is written as helium with a mass number of 4, atomic number of 2, and a charge of 2 positive. They have an electric charge of positive 2. And these radiations also are the heaviest among the three radiations. The beta radiations, they are basically electrons. They are usually formed in the nucleus of an atom when a neutron within the nucleus changes into a proton and an electron within the nucleus of an atom. This is a 0. Remember, the -1 in this electron does not represent the atomic number. It only represents the electrical charge in an electron, which is -1. And then finally, we have the gamma radiations. The gamma radiations carry a lot of energy and have no electrical charge. They are not emitted on their own, but are accompanied by alpha or beta decays. Let us now look at the properties of radiations. To do this, we will draw a diagram. In this case, we will have this kind of a box that we will call radiation source. We will also have a sheet of paper, and here we will have aluminum foil, and we will also have what we call thick lead block. So alpha particles, like we said, are the heaviest of all the three radiations. Therefore, the penetrating power of alpha particles is not very high. That means that if they come from this radiation source, alpha radiations can easily be stopped by a sheet of paper. When we get to the beta radiations, they have a comparatively higher penetrating power. That means that they can penetrate through a sheet of paper, but then are stopped by the aluminum foil. When we get to the third type of radiation, that is the gamma radiation, the gamma radiations have the highest penetrating power. They penetrate through a sheet of paper. They cannot be stopped by aluminum foil, but are stopped by thick lead blocks, and these are the gamma rays. Of course, the alpha particles have a short range of centimeters in air, and they are stopped by a sheet of paper like we have seen. Let us now look at the deflection by electric field as the next property of radiation. In this case, we shall draw a plate that we shall say it is positively charged. We'll also draw another plate at the bottom like this, which represents the negative plate. We will also have what we call a radiation source on this end, where our alpha, beta, and gamma radiations are to come from. Remember we said that the beta radiations are negatively charged. Therefore, the basic law of charge states that unlike charges attract while like charges repel. So for our case, if gamma radiations come from this end, they are attracted towards the positive plate of our electric field, and this is our beta radiations, which of course are negatively charged. On the other end, the gamma radiations, like we said, they have no charge, and for this reason they penetrate through the electric field without being deflected. Again, the alpha particles are positively charged, and for that reason they are attracted towards the negative plate of the electric field, and this is what we call the alpha particles. It is important to note that the magnitude by which the beta particles are deflected towards the plate is much less than the magnitude by which the alpha particles are deflected. The reason for this is because the alpha particles are heavy compared to the beta particles. For this reason, like you can see, the magnitude by which the beta particles have been deflected is much higher compared to the magnitude by which the alpha particles, which you have here, have been reflected. Particles. The third property that we shall look at is what is called ionizing effect. And ionizing, when we speak about ionizing, alpha particles, we shall be comparing the alpha particles, the beta particles, and finally the gamma radiations. We said that the alpha particles are the heaviest among the three, and therefore alpha particles move very slow in air, and therefore they have the highest ionizing effect on air due to their slow movement, while the beta particles have comparatively lower ionizing effect on air, and this is because they move comparatively slower compared to the alpha radiations. We also said that the gamma radiations have no charge. The absence of the charge makes them have no ionizing effect on air. I have been your teacher, Mwalimu Nyamu. Thank you, and subscribe to this channel so that you don't miss this and other exciting videos. Thank you. Until next time, remain blessed.